Close your eyes for a moment and imagine an ordinary night at home. Dinner is over, dishes are stacked by the sink, and the kitchen smells of fresh food. But beneath this peaceful surface, a silent metabolic trial is beginning. In one corner of the room, someone slowly unwraps a glazed, sugary pastry while scrolling through their phone. It seems like a harmless treat, a sweet reward to end a long day, wrapped in bright, appealing packaging. In another corner, someone else pops open a cold beer, taking a long, satisfying sip after an exhausting shift. These are two common rituals repeated nightly by millions of people without a single thought about the cost. We silence our guilt with the same comforting lie. It is just empty calories, nothing to worry about. We promise ourselves we will burn it off tomorrow with a quick workout or a healthy salad to balance the scale. We convince ourselves these are innocent pleasures, socially acceptable rewards that harm no one. But while we negotiate with our conscience, our liver does not hear these empty promises or care about our justifications. Your liver has no opinion on what is socially acceptable. To this silent, hard-working organ, both the sweet pastry and the cold beer represent the exact same thing: a sudden, overwhelming chemical flood without warning. This biochemical inundation arrives without warning, negotiation, or an orderly distribution plan. What happens inside this quiet organ when these substances enter is a story very few truly understand in detail. To understand the silent damage, we must first map the complex pathways of metabolic traffic inside us. Think of your body as a highly regulated highway network with very strict routing rules and speed limits. Not all fuel travels to the same destination or takes the same path. When you consume glucose, the basic sugar, from bread, rice, or fruit, your body activates an incredibly efficient and well-regulated system. Insulin acts as a biometric security scanner, allowing glucose to enter almost all cells. About 80% of this glucose is safely distributed to your muscles, brain, and vital organs for immediate energy. Only a tiny fraction of glucose ever reaches the liver for processing. This elegant system is designed with one fundamental purpose: to protect your liver from sudden, overwhelming metabolic overload. When glucose arrives in moderate amounts, the liver manages it with ease. But the real trouble begins when our modern dietary choices bypass this intelligent distribution network entirely and flood the system. Now, consider fructose, the concentrated sugar abundant in sodas, processed juices, and packaged sweets. Fructose does not obey the normal traffic laws of human metabolism or trigger the same insulin response. Fructose asks for no permission, triggers no insulin response, and completely avoids systemic checkpoints. It heads directly to the liver, dumping its entire chemical load without any protective filters. Ethanol, the alcohol in your favorite beer, wine, or cocktail, behaves in the exact same lawless manner. It completely eludes general body distribution, crashing straight into the liver with its full chemical load. The mathematical reality of this is brutal. While glucose distributes its load across trillions of cells, fructose and ethanol concentrate 100% of their metabolic impact on a single organ. It is as if every bolt of lightning from a severe electrical storm repeatedly struck the exact same power transformer night after night, leaving absolutely no time for the system to recover or repair. Eventually, the biological transformer fails. This is why fatty liver disease, once linked solely to heavy alcohol abuse, is now skyrocketing in children and adults who rarely touch a single drop of liquor. The invisible culprit is highly processed dietary fructose quietly slipping into our modern food supply. To see how it destroys our health, we must zoom directly into the hepatocyte cell membrane. Inside the liver cell, we find a microscopic factory. The damage here is not sudden or dramatic. It is a slow, silent erosion of cellular machinery that goes unnoticed until the damage is already done. When glucose enters the hepatocyte, it is greeted by a highly regulated enzyme called hexokinase. Think of hexokinase as a meticulous receptionist managing a balanced, orderly queue of incoming work. Hexokinase ensures that glucose enters metabolism in a controlled, step-by-step manner. It constantly monitors cellular energy levels and slows down processing when the cell already has enough energy. Fructose, however, meets an entirely different enzyme called fructokinase. This enzyme has a critical flaw. It lacks any feedback inhibition. It has absolutely no biological brakes to slow it down. Fructokinase does not care if the cell already has plenty of energy. It simply processes incoming fructose at maximum speed, ravenously consuming ATP, the cellular energy currency, without limits. This rapid, uncontrolled processing drains ATP at an alarming rate. The sudden drop in energy triggers a cellular crisis, converting depleted ATP into AMP and finally into corrosive uric acid. Uric acid is not just a harmless waste product, it directly interferes with nitric oxide, a crucial molecule that tells your blood vessels to dilate and relax, maintaining healthy blood flow. As nitric oxide drops, blood vessels constrict, subtly raising your blood pressure. This creates cardiovascular tension while simultaneously driving severe oxidative stress inside the liver tissue. Uric acid also promotes insulin resistance, causing hepatocytes to ignore insulin signals. This disrupts the liver's ability to regulate blood sugar, setting the stage for systemic diabetes. Meanwhile, the rapid breakdown of fructose floods the liver with raw materials, activating a process called de novo lipogenesis. This is the direct manufacturing of new fat from simple sugar molecules. Excess metabolites leak from the mitochondria into the cell's cytoplasm, activating acetyl-CoA carboxylase. This enzyme acts as the main ignition switch for the liver's fat-making machinery. The liver begins rapidly manufacturing triglycerides from fructose. These newly formed fats accumulate inside the delicate hepatocytes as tiny, suffocating droplets of lipid crowding the cell. Imagine a small apartment where new furniture arrives every day, but nothing is ever thrown out. Slowly, the hallways narrow, and eventually, there is no room left for the residents to live or breathe. This is how fatty liver disease develops, silently, without any dramatic symptoms or early alarms. It is a slow, progressive accumulation that compromises your liver's vital functions from within. Now, let us examine ethanol. The metabolic pathway of alcohol is different, but the ultimate destruction it leaves in its wake is remarkably similar to that of processed dietary fructose. When ethanol enters the hepatocyte, it is immediately processed by an enzyme called alcohol dehydrogenase, or ADH. This enzyme converts the alcohol into a highly toxic substance called acetaldehyde. Acetaldehyde is highly toxic, far more dangerous than the alcohol itself. Inside the cell, it behaves like a corrosive acid, binding to delicate proteins and warping their essential structures. It also binds directly to DNA, forming chemical adducts that damage genetic material and increase mutation risks. With every drink, the risk of permanent cellular damage grows silently. But acetaldehyde does not work alone. Its production generates massive amounts of NADH, a molecule that carries electrons. This creates a severe imbalance in the critical NAD plus to NADH ratio. Biochemists call this a redox imbalance. It completely halts the normal burning of fats. The mitochondria rely on NAD plus to oxidize fatty acids, but that supply is now completely drained. With beta oxidation frozen, the liver cannot burn existing fats. The fatty acids pile up at the mitochondrial gates, leaving the liver with no choice but to store them as lipid droplets. This answers a common mystery why frequent drinkers develop fatty liver even on a low-calorie diet. It is not about the calories. It is a redox block that suffocates mitochondrial fat burning. Yet, there is a third, silent accomplice in this metabolic crime scene: your gut. Both excess sugar and alcohol severely damage the delicate integrity of your intestinal lining over time. The small intestine is lined with a single layer of cells held tightly together by protein structures called tight junctions. They act like secure mortar between protective barrier bricks. When processed sugar and alcohol repeatedly irritate these tight junctions, the cellular bricks begin to separate, creating microscopic gaps in your body's primary immunological firewall. Through these tiny gaps, bacterial fragments known as lipopolysaccharides, or endotoxins, leak into the bloodstream. These toxic components should never escape the digestive tract. Once in the bloodstream, these endotoxins travel directly through the portal vein, the major vascular highway, connecting your digestive system straight to your waiting liver. When these bacterial endotoxins reach the liver, they trigger an immediate immune response. Kupffer cells, the liver's resident immune sentinels, sound the alarm and prepare to attack. Kupffer cells release a flood of pro-inflammatory cytokines. This ignites a chronic, low-grade inflammatory fire that smolders silently within the delicate hepatic tissues for years. This persistent inflammation does not hurt. It has no obvious symptoms for years, but it slowly weakens the liver's structure and impairs its ability to filter daily toxins. Even a moderate daily intake, a single soda with lunch or a beer every night, can be enough to keep this inflammatory fire burning continuously, never allowing the liver to heal. If chronic inflammation is the fire, fibrosis is the thick scar tissue left behind. Hepatic fibrosis is one of the most dangerous and underestimated stages of cumulative liver damage. Persistent inflammatory signals eventually activate a specialized group of dormant cells called hepatic stellate cells. Normally, these cells quietly store vital vitamin A, but under chronic inflammatory stress, stellate cells transform into hyperactive factories, producing massive amounts of collagen, the tough, fibrous protein found in scar tissue. This collagen deposits between liver cells like liquid concrete poured into a delicate, flexible garden. Slowly, the soft, living tissue is replaced by rigid, inactive scars. At first, this scarring is microscopic and completely silent. You feel absolutely normal, unaware that your liver is slowly turning into stone beneath your ribs day by day. This invisibility is the cruelest trap of fibrosis. By the time symptoms like fatigue or abdominal discomfort appear, the scarring process has often been silent for decades. While fibrosis advances, the mitochondria, the cell's power plants, remain under constant siege. Highly unstable reactive oxygen species, or ROS, are produced in massive excess. These free radicals act like cellular sparks, causing oxidative damage to membranes, proteins, and DNA. They overwhelm the cell's natural antioxidant defenses very quickly. Glutathione, your body's master antioxidant, is rapidly depleted as it tries to neutralize the alcohol and fructose storm. Without it, the liver cells are left completely defenseless. As mitochondria fail, the liver's ability to oxidize fat drops even further, worsening fat accumulation. This vicious cycle deepens insulin resistance throughout the entire body. Triglycerides spill into the bloodstream, elevating systemic VLDL cholesterol. What began as a simple nightly indulgence has now completely rewritten your body's global metabolism. So, we must face the ultimate question. Which is the true silent killer, sugar or alcohol? The uncomfortable truth is that both are equally devastating, just in different ways. Alcohol is an acute, direct toxin. It produces acetaldehyde, which immediately damages DNA and proteins, creating a redox block that freezes fat metabolism almost instantly. Fructose is a slower, stealthier assassin. It does not produce an immediate toxin like acetaldehyde, but it slowly suffocates the liver with fat, depleting ATP and raising uric acid. If alcohol is a repeated explosion inside the factory, fructose is an endless delivery of clutter that blocks the hallways until the entire operation grinds to a complete halt. Your liver is a magnificent 1 kilogram biochemical laboratory working nonstop to keep you alive. It filters toxins, regulates blood sugar, and produces essential proteins. It did not evolve to handle the extreme chemical loads of the modern diet. It was never designed to process liquid sugars with every meal or alcohol on a near daily basis. Fortunately, protecting your liver does not require monastic discipline or extreme deprivation. It requires smart, biology-backed strategies to reduce the daily metabolic load. The first key principle is using your muscles as a shield. Physical activity mobilizes GLUT4 transporters in muscle cells, allowing them to absorb glucose directly from the blood. If you exercise before consuming something sweet, your muscles soak up the glucose, preventing it from reaching your liver. You effectively intercept the metabolic storm. The second principle is using soluble fiber as a traffic controller. Fiber forms a viscous gel in your gut, slowing down the absorption of sugars and protecting the portal vein. Eating fruit with its natural fiber is metabolically night and day compared to drinking processed juice. The slow arrival of fructose gives the liver plenty of time to adapt. The third principle is supporting your liver's detoxification pathways. Alcohol depletes glutathione, but precursors like N-acetylcysteine or NAC can help restore this shield. B vitamins, especially thiamine and B6, are heavily depleted during alcohol metabolism. Replenishing them through diet or smart supplementation helps maintain enzymatic balance. The fourth principle is respecting your liver's recovery windows. The liver has an incredible capacity to regenerate, but it requires time and the complete absence of toxins. Giving your body consecutive days of rest from alcohol and processed sugar allows the hepatocytes to repair existing damage and clear out accumulated fat droplets safely. The fifth principle is conscious substitution. Choose sparkling water over soda, eat whole fruit instead of drinking juice, and save alcohol for truly special, rare occasions. These are not radical changes, but over time, their biological impact is profound. You are shifting your metabolism away from silent erosion and toward active self healing. Your liver is the quietest champion in your body. It manages over 500 vital biochemical functions every single day without ever complaining until it is almost too late. Now that you understand the biochemistry of the silent trial, the choice is yours. Respect this incredible inner factory, protect it from storms, and subscribe for more health science.